Hello everyone, welcome to the channel. Here in this video I will be solving example 2 given in page number 128 of chapter 6 measuring space, perimeter and area. Here the question is in the figure 6.13 you can see this figure. We see points P, Q and two paths connecting them. One path is the red line and the another path is the blue line. The first path is made up of the semicircle A. So this path is made up of a semicircle A. The other path is made up of three semicircles B, C and D. Which path is longer? Choose one. First one, path A is longer. Path B, C and D is longer, or the two paths have equal length. So that option based question is there, but we need to solve this question. Let's see and let's understand what is happening. So if I consider this as a circle, so if I just complete this circle, it will be getting formed in this way. This is one circle. Let us consider this circle is having the diameter as x. If I complete this circle, so it will be having a diameter y. If I complete this circle, I will consider the diameter as z. So, and if I consider this bigger circle, if I complete this bigger circle, it will be having a diameter x plus y plus z. So if I name this circle as circle 1, circle 2, circle 3, circle 4. So here circle 1 is having diameter as x plus y plus z. Circle 2 is having diameter as x. Circle 3 is having diameter as y. Circle 4 is having diameter as z. So I have written the diameter of the circles. Now I need to find out the path length of A. Path length A we need to find. This path length is actually a semicircle, a part of semicircle. Now because our target is to find out the length between the point P and Q, that is the target in this question, and we need to just check whether the path length is longer or shorter or both are equal. So here actually here it is a point P and here it is point Q. If I just draw the path length A, this is an arc. So I need to find here arc length A, and arc length A we need to find. So it is given as theta upon 360 multiply with 2 pi r. So what is the angle subtended by it? So angle subtended by it is 180 degree here. So 180 divided by 360 multiply with 2 pi r. 180 1 ja, 180 2 ja, because the angle subtended at this point from point P to the center of the circle, from point Q to the center of the circle, the angle is 180. So I have taken as 180 degree divided by 360 multiplied with 2 pi r. 180 1 ja, 180 2 ja, then 2 and 2 cancel, So here it is pi r. So I get it down as pi r, the arc length A. Now let us find out path length B, path length C and path length D together. Then we need to compare that whether these three together and single A length is comparable in what way. So let us find for B first. So here it is, this way it is given, and here it is point P, and I can consider point K. So here also the angle subtended, whatever the center of the circle is there, this is the diameter of the circle, and if I consider somewhere here the center of the circle, the angle subtended from these 2 points, that is the arc, that is the arc B, is, we need to find here the arc length. Arc length B is given as theta upon 360 multiplied with 2 pi r, and here theta is given as 180 divided by 360 multiplied with 2 pi r. So 1 ja, 2 ja, 2 and 2 cancel, here it is pi r. Now for the arc C, it is given in this way. Here I am considering the point KL. Here it is K, here it is L. This is arc C. Here the diameter of the circle is Y. So arc length C is given as theta upon 360 multiplied with 2 pi r. So theta is given as again 180, the angle subtended by the arc edges or arc points K and L to the center, it is 180. 180 upon 360 multiplied with 2 pi r, again it will be pi r. Now the third one is, here it is given L and Q. So the diameter of the circle is Z and here the arc is T. I need to find arc length. Here also the angle subtended is 180, so I am writing 180 degree divided by 360 multiplied with 2 pi r. So again it will be remaining pi r. Now, now the point is that in the first circle, this the semicircle part, the radius, the diameter of the circle is x. So what I will do, pi is multiplied with radius of circle. So here the radius of circle will be, r will be equal to what? X upon 2. So x upon 2 I will write down. So it is pi x upon 2. Now I need to add these three first. Pi r plus pi r plus pi r, it is 3 pi r, or no, it will not be in this way, because in the first circle, in the first, okay, somewhere I have done the mistake. We need to resolve this one. First thing is that here it is a mistake. Diameter of the first circle is what? X plus y plus z, that is the diameter of circle. Okay, so as per this, the radius of circle will be x plus y plus z upon 2. So for this, pi r is the result. What I will do, pi is multiplied with radius of circle. Radius of circle is x plus y plus z upon 2. So that is the final answer. Now for the second circle, diameter of the circle is x, so radius will be x by 2. For this third circle, diameter of the circle is y, so radius will be y upon 2. And for the third circle, the diameter is z, so radius will be z upon 2. Now I need to add these three. So when I add, pi will be taken as common. Pi will be taken as common. It is x by 2 plus y by 2 plus z by 2. Now I can write down in simple form, pi multiply with x plus y plus z divided by 2. Now you can see this result that path A is the result as pi upon 2 multiply with x plus y plus z. That is the result. When path B, C and D is added together, again we have got the same result. So we can see that the two paths have equal length. Option 3 is the correct answer. That two paths have equal length. So that is how we solve this question. Hopefully you have understood about it.